Hi everyone, welcome to Big Data and Data Science Center of Excellence. We as a Big Data COE provide the following courses: data science, machine learning, natural language processing with Python, NLTK, Hadoop Big Data, Big Data Analytics, and Business Analytics with R. And these are the courses we teach: Big Data with Hadoop, MapReduce, HDFS, Big and High for analytics, HBase, Cassandra, and MongoDB for NoSQL, Mahout for machine learning, and Python for text analytics. And when it comes to data science, we teach data pre-processing, statistics, machine learning, and optimization with R language in Python, visualization, rapid fire analytics with Tableau and QuickView. And as all you know, Harvard Business Review has said data scientist is the sexiest job of 21st century. Let's get more into this data science. Okay, so coming to me, my name is Kumar and I'm a chief data scientist working in a startup company, and that is Big Data COE. So what is data science? Why data science? Applications, job opportunities, course structure, key takeaways. Okay, this is what we'll be seeing in this particular core uh, demo. So, what is data science? Everyone has this question. According to me, data science is science which you apply on data. That's it. So, the key word in data science is science. And data science is a combination of computer science, mathematics and statistics, and domain knowledge. So all this contribute towards data science. And what are the key disciplines of data science? The key disciplines of data science are mathematics, statistics. These contribute to the algorithm part, and advanced computing, visualization, hacker mindset, domain expertise, data engineering, and scientific method. And whoever is willing to pursue a course in data science, or whoever is trying to become a data scientist, should be able to master an at least three. When I say three, if you want to be a big data and data science architect, you should be good with data engineering, hacker mindset, and statistics. And if you're willing to become a data scientist, then you should be good with visualization, hacker mindset, and scientific methodologies. And if you are an experienced guy and you are having enough domain expertise, then you should be good with statistics and visualization. So a combination of any three would make you a data scientist. Okay, but in general, data scientists should be good with everything. When I say everything, I as a data scientist know Hadoop, know big data, or know Pig and High, I know Mahout, I know Spark, I know Apache Flume. And when it comes to data science, I know machine learning, I know data pre-processing with R and Python. So lots of things. I even use Tableau and QuickView for rapid fire analytics. Okay, so data science is something like in which you have to learn a lot. Okay, and why data science? The main reason for the craze in data science is the explosion of data, that is big data. Okay, and yep, when we have big data, now that we have systems for storing and processing the data, what algorithms can you apply on the data? That's a big question everyone is having, right? That, and there are many new methodologies that are coming up for predictive analytics, for customer segmentation, for clustering of news. There are many more new things that are coming up. Okay, and yep, as I already told you, data scientists are 6 years of 20th century, and that is so true. I see it. I personally feel we are unicorns. And why data science? For data analysis, for predictive analytics, for beautiful insights on data, for feature extraction on large data sets, visualization for better understanding of data. You can build even recommendation systems like Amazon did, and there are many more applications. Okay, and we'll see the first application of data science in retail sector. See, you see the scenario, right? There are many things to sell upon. So and the first question would be what to sell. The second question would be who is a loyal customer. When I say loyal customer, who is the most repeated customer, most frequent customer, and most valuable customer. How would I find a loyal customer when I have millions of customers? Data science does it. And seasonal markdowns, yes, before Christmas, Thanksgiving Day, I'll be having seasonal markdowns, right? So seasonal markdown, according to me, is cleaning the warehouse. I have many things in my warehouse stacked up. What I'll do at that point of time is, during markdowns I will sell this particular goods at cheaper prices, and I'll clean my warehouse. And demand prediction, yes, it is important, right? A product which is having high demand today, maybe in the coming month it might not have demand. So how are you going to measure demand for a particular product? Okay, thus comes as applications of data science in retail sector. Now applications of data science in telecom sector. You see, the world is connected with this telecom. Everyone has mobile phones and everyone are connected on telecom network, right? So in telecom sector, the biggest problem would be churn. When I say churn, what is the probability that a customer of X company will change to another customer of Y company? That is churn. How would I predict a customer would leave my company and take a membership in another company? Okay, and not only that, predicting server outages, there might be chances, not there might be chances, there are chances every day that a server will outage will happen, and all the towers that are sending signals to this particular server cannot communicate for at least 10 to 20 minutes. So that way server outage will bring huge losses to the company. Okay, and applications of data science in clinical trials. When I say in clinical trials, generally what happens is a pharmaceutical company or a medical healthcare science company will recruit doctors, and doctors will in turn recruit patients and administer medicines on patients. Now I have a question. What if doctor what if doctor did not administer medicine on patient? Instead of doing that, he randomly entered some values and published the same. How can a pharmaceutical company believe that whatever the data that is being sent by doctor is true? Difficult, right? So we can find it that we call it as fake pattern recognition. And yes, this is a classic example of data science in farming. Depending upon soil fertility levels, potassium levels, magnesium levels, all of the components that are related to soil, and depending upon the amount of water that is present on reservoir and rainfall, can I predict the acreage? Can I predict what would be the demand for a particular fertilizer? Can I predict the crop yield in the coming year at same point of time? What would be the seasonality in this case? Yes, all this can be done with data science. And applications of data science space research. See, the image which you are seeing now is actually pretty big. When I say actually pretty big, it might be kilobytes in this particular presentation, but it will be in mega to gigabytes. The reason is, if you even zoom it for 20 times, you should be able to see the Milky Way clearly. Okay, so NASA, ISRO, all those take images, and each image size will be in gigabytes. Okay, and after downloading the images, how would I classify that this is Milky Way and this is Milky Way, this is planet, and this is star might be. So how would I do that? That can be done with data science. We can do automation to find particular image patterns. That can be done, and that is an application of data science. And yes, applications of data science in banking sector. Oh, from the past 20 or 30 years, I have many records of my customers. When a new customer comes, can I provide him loan or not? If I provide him loan, will he default the loan or not? If he defaults, what will be the amount, and at which point of time he'll start defaulting? How will I know all this? This can be done with data science. Since we already have the historical data of many years, we can in turn build a machine learning predictive analytics model on top of that, and yes, we can do this. And applications of data science, social networking, yes, you see this every day, right? When you log into Facebook, and after that you are trying to book tickets in some websites. After 5 or 10 seconds you will be seeing an advertisement in Facebook saying that cheap tickets to Singapore, cheap tickets to Malaysia, cheap tickets to Hong Kong. So you got it right. So they are trying to advertise by mining your data, mining your actions on other websites. And not only that, recommendation. When I say recommendation, the classic example would be Netflix movie recommendation engine, and at the same time Amazon book recommendation engine. It is amazing, right? All this are done with data science. And one more classic example of data science in insurance company is coverage options. Take it this way: you as a customer came to my office, and I generally have many coverage options, okay? And it will take at least 2 to 3 hours for you to decide on which plan you should go, and after that we'll go ahead, okay? So that way each customer is engaged for 2 to 3 hours. What if I could use data science now and try to minimize the coverage options and provide him the best coverage options based upon the past historical data? And that way, if I could close this particular session with the customer within 30 minutes, I would save 2 hours per customer. That way, if I get 30,000 customers per year, I'll be saving 90,000 hours. That is data science. And not only that, I can calculate the customer risk, right? Based upon the customer risk, I might be providing renewal options, new renewal options, and many more things, okay? And yep, fraud reduction is required everywhere. When I say fraud reduction, you are using your credit card at place X. Nay, your credit card is being used at place X, okay, and you are at place Y. How can I correlate your position on maps and your position where your credit card is being used, and how would I find the distance? And then I could come to a decision saying that okay, customer is not currently using the credit card, someone else is using the credit card, and we will call you saying that hi sir, your credit card is being used in another place. Is that you, or is that your friend, or is that someone? If I say it is me or my friend, I'm okay. If not, I will say I will cancel that transaction for security reasons, okay? And applications of data science, robotics, yes, in robotics there is lot of machine learning happening, okay? In automobile sector, yes, machine learning is required, right? Automatically, if you want to drive a car, obviously you need data science for that. And not only that, before launching a new car, I should do market analysis, yes or no? Yes. What is the brand value of my particular company? What should I present to customers? What are they liking in my product, and what they don't like in my product? Okay, all this come under data science. And this is a classic example of supply chain management. Okay, I will show you how this is classic. Give me a second. Think that you have 1,000 trucks that are having a delivery tomorrow, okay, and all these 1,000 trucks should reach here by 2 p.m. tomorrow, and currently the time is 2 p.m. today, and 2 p.m. tomorrow there should be a delivery happening. And Customer will accept only between 2 to 4 p.m. If you come after 4 p.m., you have to wait till next day 2 p.m. Okay, so that is the complexity of scenario. And I repeat again, there are 1,000 trucks. Okay, and the current time is 2 p.m. and tomorrow by 2 p.m. you have to, you have to deliver the goods between 2 to 4 p.m. Okay, between 2 to 4 p.m. and the total kilometers that it has to be covered is around 1200 kilometers. Now tell me, how will data science help me? With the help of data science, I will get every possible detail of cost of driver driving patterns. A driver might be traveling at 80 kilometers per hour, but he is carrying an oil tanker. Is it required? It's no. I would get to know about that and I'll ask the driver to stop it and ask him to go slow. And I said right 1200 kilometers in 24 hours. So what could be the speed at which they can travel? So it should be, it is enough if we travel at 60 kilometers, 50 kilometers per hour. 50 kilometers per hour is absolutely fine. Okay, 50 kilometers per hour. Okay, 50 kilometers per hour you can reach on time. But what if driver is traveling at a speed of 80 kilometers per hour and he reached this location by 11 a.m. and from 11 a.m. to 2 p.m. he's taking rest? I don't want that. Okay, because if I travel at 50 kilometers per hour and if I travel at 80 kilometers per hour, I would be losing 6 liters of petrol. 6 liters of petrol, okay, or diesel, petrol or diesel. It's very costly, right? It's around $1, right? It's around $1. 1 liter is $1, so you'll be losing $6 per truck. Then for 1,000 trucks, $6,000 is what we lose. So with the help of data science, we'll be tracking. When I say with the help of data science, obviously we'll be having GPS on every possible truck. We'll get the data from GPS, and after that we'll store using Hadoop big data, and then we'll apply our machine learning algorithms to find driving patterns of the driver. And not only that, many more applications will be coming up very soon. But this is a classic example. Okay, and not only this, where should I put my warehouse so that I can distribute the goods very well across all the stores? All this are a problem. Okay, and we as a data scientists are ready to help. And applications of e-commerce, you know all this, right? E-commerce, who is my loyal customer? Personalized offers, what I can provide, what seasonal offers can I provide, what are the current trends, what is the demand, all this. Okay, and yes, email ham and spam, how you're going to do that? That comes in a data mining. Okay, text mining actually. So even that should be a part of data science, obviously, right? So we can do email ham and spam. When I say current trends, how did Nate Silver predict Obama is going to win the elections? How did he do that? And data science is a key part for this. When I say data science, data mining actually is a key part. And image processing, yes, we do need image processing. We do need neuroscience image processing to find out many things that are happening. Okay, and pattern recognition. Yes, how would I find the patterns that are happening in stock markets? How would I find the pattern of rainfall? How would I find the pattern of weather conditions across worldwide? How would I find the patterns of traffic? How would I find the patterns of many more things? Okay, everything will be having a pattern. Maybe pattern from buying a product, maybe pattern of a customer selling a product. Okay, so there are many things. And security checks, yes, even for security checks we can install a camera, and an ATM center, and after that we can have a program which will be finding out guys who is creating menace inside ATM. That itself will say that okay, something is happening and we should respond. Okay, and optimization, yes, it is required in all sectors, and air traffic control. Take this case: your flight is delayed by 4 hours due to heavy rainfalls. Okay, if you are told about this 2 hours before, you need not travel to airport, and that way you'll save a lot of time. If if we do this, what happens is we gain the loyalty of the customer, and customer starts believing us, saying that okay, since you already intimated me 2 hours prior to uh, delay, I'm very thankful, and you saved my time a lot. Okay, so this way it happens. And not only that, what if I'm traveling to Japan from China, and I've seen some hurricane passing to Taiwan. Okay, so what I can do is I can just change the route, the best and the shortest and the best possible route, which is having less natural calamities that are happening. So that way also I will still retain the loyalty of customer. And energy sector, yes, the main thing in energy sector is usage patterns. How would I make sure that the usage patterns is stable across all the consumers of power? And outage prediction, if I could find the weather patterns all over the world, then I will decide where should I place my windmill to generate power. You got it right. So that can be done with data science. And in medical science, take this way. I'm a doctor. I attended you, and when I attended you, I got all the details that are required and well presented this way. What do you think? It is amazing, right? And this can be done with data science on medical science. And recommended systems, I've already told you this, right? So based upon users and based upon items bought by users, we can do recommendations. And are you willing to become a data scientist? My question is for you guys. Okay, my question repeats again: are you willing to become a data scientist? The answer should be yes. If you're a data scientist, you will be having a great future for the coming 15 to 20 years. Okay, and coming to job opportunities, if you see the jobs percentage growth for data scientists is increasing, and this is brought from Indeed. Okay, and after that, and in LinkedIn you'll see like analytics and data science job starters, and it is increasing a lot, a lot. It's an exponential graph actually, right? And if you see job opportunities in every sector, there is a lot of demand for data scientists: pharmaceutical, computer software, internet research, IT and services, biotechnology, marketing and advertising, higher education, financial services, defense and space. Yes, everywhere there is a lot of demand for data scientists. And yes, in our course of data science, we'll be using R language. R is a statistical software language, and it even has machine learning algorithms and optimization algorithms, and it even has text analytics packages. Okay, so R is very simple, easy to use, yet powerful. Okay, and the percentage of matching job postings for R, if you see, that increasing exponentially. And I have a question: do we really need SAS and SPSS when we have R, which provides everything, and we do even have Python, which has many packages? Then why are we trying to use SAS or SPSS? And if you see the demand, top one lies is Python and machine learning, the next one is R and machine learning, and the next one is SAS and machine learning. So SAS is having a heavy competition from R and Python. And job opportunities, this graphs on x-axis you have year, and on y-axis number of Google Scholar hits for each software. If you see R rules. And job opportunities, yes, SQL still has the highest job opportunities, but followed by is R, and after that Python, Hadoop, JavaScript, Tableau, Mahout, Ruby, SAS and SPSS. If If you see SaaS and spaces, demand is very low these days. And big data, big paycheck. Yes. So this is the salary ranges that you can expect uh, if you are staying in United States of America. Okay. And now what we'll say is we will see the course content. Okay, the course content I will be taking up in this particular data science course. Okay, module 1 would be data science essentials. In data science essentials we will be saying introduction to data science, what is data science, business modeling, understanding data. When I say understand data, what are the data types we have, what is this data pre-processing, transformation, how do I do approximations and estimations, how do I analyze a network and graph, how do I represent data graphically and analytically, and what are the applications of data science. We can discuss that in detail when you join this course. And reviving with R, as I said, right, we will be essentially dealing with R, and R is a statistical software tool that is used by most of the academicians and PhD graduates PhD guys who are uh, pursuing their PhD on something related to data. Okay, they will be using R for sure, definitely, or they'll be using Python. R and Python are very good languages for data pre-processing, machine learning, statistics, optimization, text analytics. Okay, and Python. And after this is done, we'll be teaching you basics of Python, and after that, how to handle data with Python and R. Okay, once this is done, we'll not teach Python anymore. It's up to you. If you want to learn Python more, you can go ahead. We'll provide all the resources that are required. And after that will be the unit 4 would be data analysis, explorative basic data analysis, data exploration, qualitative and quantitative data, central tendencies, mean, median, and more. All these are basic statistics. Okay, a range, variance, standard deviation, correlation versus causation. Okay, and data visualization. Yes, in data visualization we'll be teaching you Tableau, R, ggplot, and Google visualizations. All this will be taught. And data visualization even will teach you how to build a story, on what basis you can support your story, and all this. Okay, and processing unstructured data, how you are going to do text processing. Okay, how you are going to do sentence splitting, tokenization, find unique words, punctuations and stop words, incorrect spellings, how we are going to do that. Data science tools like R and Python can easily do this. Okay, and basic natural processing. When I say basic natural processing, we'll be having a series of steps that should be done before we do sentiment analysis. All will be taught here in detail. Okay, and after that we have a case study which we'll be seeing when we are taking up this course. And after that we have probability and statistics. This comes under predictive analytics. Okay, and probability and statistics will be teaching you probability concepts, statistical distributions, normal, binomial, Poisson, exponential, and central limit theorem, analysis of variance, Bayesian statistics, useful statistical inferences about business outcomes. And we'll be seeing now statistical analysis. Okay, how we are going to forecast what happens in the future. We have two best models called ARIMA and Winter, so we can use that for this purpose. And introduction to regression. Even we will even teach you how to do forecasting with the help of regression, linear and multivariate regression also. And as I said, right, we'll be teaching you Tableau for rapid analytics. I love this tool for all good reasons. And after that we will be seeing applications of text analysis, data collection and structuring, text classification applications, text analysis. Okay, how we'll be showing you how to download data from Twitter, how to access data on Twitter, how to perform some data processing steps on this particular extracted data. All will be taught to you. And social media analysis, data collection and structuring, mining social media. Okay, when I say data collection and structuring, data collecting from Facebook and Twitter, if you could put them in a better format for us to easily work on it, it would be great, right? And mining social media, topic mining and current trending. Maybe you and me are speaking on WhatsApp more about some good actor, okay? And everyone has started speaking about this actor, saying that this actor has done something wrong, okay? How will Google or Facebook come to know? They will do some simple text analysis and will see that, okay, this particular word of this particular actor is repeating more number of times. Let's see, okay? And next comes introduction to machine learning. We'll be teaching you recommendation systems, we'll be teaching you decision trees, we'll be teaching you what are the similarity measures, decision tree classifier, movie ratings and recommendations. And the best one is principal component analysis, okay? And next comes predictive modeling, pre-processing for analytics, analyzing the goodness of model, okay? On what base I can analyze the model, and after that validation of model, confusion matrix, ROC curve, lift and case test. And supervised learning, we have again in machine learning we have two things, supervised and unsupervised. Supervised learning we know what to do, and unsupervised learning we don't know what to do. And in that I'll be teaching you clustering and clustering techniques. And as a clustering, yes, obviously you'll be going ahead with similarity measures for grouping objects, and partition clustering, analyzing clustering results, okay? And there are many other techniques like support vector machines, ensembling techniques, and all this will be taught to you. So in detail we'll be teaching you data pre-processing, data visualization, statistics, machine learning, predictive analytics in detail. If you have any questions, you can please post me on you can please contact me on bigdatasciencecoe@gmail.com. Okay, thanks a lot for listening to this particular recording. Hope you had a great session. If you have any more questions, I'll just repeat again. Please drop me a mail on bigdatasciencecoe@gmail.com. Thanks a lot for your valuable time. Bye. Take care.